Hello everyone, welcome to today's session, Sec 321. My name is Fola Bolodioku and I am a security engineer on the Shield Response Team based out of Cape Town, South Africa. The topic of today's session is how Shield Advanced customers can get ahead of the curve with Shield response escalations. Let's get started. The agenda of today's topic will see us discuss how Shield Advanced customers can prepare for Shield Advanced escalations. We'll discuss lessons that the Shield Response Team has learned from working with our various Shield Advanced customers during escalations. We're going to talk about common mistakes we've observed and what you could avoid in your own operations. Finally, we'll round off with some simple yet effective tips and tricks to remain resilient to DDoS events. Well, before we proceed any further, let's define what the Shield service is. AWS Shield is a managed DDoS protection service as well as a managed application security service. It's available in two tiers. The first tier is known as AWS Shield Standard. Shield Standard is our basic DDoS protection service that offers protection against the infrastructure layer on all AWS services. For comprehensive infrastructure layer protection, customers should use our edge services such as Cloudfront or Route 53, as these contain an always-on and inline mitigation service that will scrub off DDoS traffic for all known infrastructure layer attacks. A second tier of Shield is called Shield Advanced. Now, Shield Advanced is our more advanced service for DDoS protection that extends protection from the infrastructure layer up until the application layer. With Shield Advanced, customers get access to WAF and Firewall Manager at no additional cost. Customers also get access to the Shield Advanced Response Team, which is the main reason why we're going to have this session today. The Shield Advanced Response Team is available to customers. Shield Advanced Team is available to customers at a 24/7 basis and available to customers during, before, or after an attack. In order for us to expand on this point a little bit more and understand the differences between these two tiers of Shield, I'm going to quickly overlay the Shield Response or Shield Advanced services or Shield services with the more common AWS Shared Responsibility model. In the diagram, you can see we have the security of the cloud, where AWS is responsible for securing all AWS infrastructure at the region level, at the availability zone level, and at the edge services level. With this, we are concerned with ensuring that all AWS customers, including our Shield Standard or the basic protection customers, have availability protected against all infrastructure layer attacks. With Shield Advanced, we improve or we add on to this protection by including custom mitigations that customers can use when they need to escalate when they need to mitigate more advanced events or more advanced attacks. I'm going to now talk about the major value add to a Shield Advanced subscription, which is known as the Shield Response Team, aka the SRT. The Shield Response Team is a group of security engineers that are available to customers 24/7. The Shield Response Team is primarily responsible for ensuring that we maintain the uptime of our customers' services during a DDoS escalation. The Shield Response Team is available to Shield Advanced customers either before or during or after an attack. For Shield Advanced subscribers who want to reach out to the Shield Advanced team outside an escalation, please reach out to your account team, your technical account team, to schedule a meeting or an engagement with us to discuss any questions you may have on how you can remain resilient to DDoS events. The Shield Response Team is also responsible for protecting Amazon.com retail site as well as other AWS services. As part of our mitigation strategies for protecting DDoS events, the Shield Response Team considers all applications on a case-by-case basis. In doing this, it means that we ensure that if a customer is seeing an application level DDoS event, we assist the customer in creating WAF rules that assist in mitigating or stemming the request flood that the customer is witnessing at the time in order to restore application availability as soon as possible. We also, for more advanced network layer attacks, we offer customers custom mitigations that are available to ensure that the customer can mitigate attacks at that layer. When we realize that we need to increase our strategies for the network layer, we consult or we work closely with the AWS networking teams, which ensure that we can shift your application traffic either at the application, we can shift the application traffic at the network layer using our pairs with our transit providers. Finally, the Shield response team provides architectural reviews and recommendations to ensure that your application stay up during a DDoS event and become resilient to DDoS events altogether. Now, we're going to break this session into a before, a during, and an after scenario. In the before, I want to talk about what customers should ensure that they do set up prior to ever even having a Shield advanced escalation or a DDoS event. First things first is, before ever reaching out to the Shield response team for an architectural review or an engagement or a consultation, customers should ensure that they have reviewed the best practices contained within the AWS DDoS white paper. These best practices contain reference architectures that customers can refer to depending on their use case. For gaming customers who rely heavily on infrastructure layer protocols such as UDP and TCP, there are certain best practices that you should comply to ensure that your applications remain resilient. This is going to be quite different to customers who have TCP 80 or TCP 443, which are web-based applications in their infrastructure. We recommend customers review this white paper with the best practices and align as closely as possible to the recommended best practices. An important philosophy within this white paper is that customers reduce their attack surface at all costs. This ensures that the attackers who intend on bringing your availability of your website or impairing the service of your website or web application have a lot less to work with. In doing this, customers can implement Amazon VPC security mechanisms such as VPC security groups, as well as network access control lists. Further to that, we highly encourage customers who use our content distribution network called Cloudfront to ensure that they're protecting their origin, because the application load balancers, whatever target or origin that your Cloudfront distribution uses to send traffic to, it's possible that malicious actors could discover that by probing and scanning, and they bypass all the protections that a content distribution network provides for your application. So it's important that you lock down access to your origin to enforce that it only allows requests or traffic from your Cloudfront distribution only. Finally, for things to do prior to an event, it's important that customers have reviewed playbooks and have an escalation channel internally that the security engineers and the incident responders are quite familiar with, so that during an event they don't spend more time and they don't elongate the mean time to mitigate. Rather, they have a known path to follow in terms of confirming that the availability or impairment of the application is actually true and not an anomaly. And in doing so, they can escalate to the right channels and eventually reach out to the Shield response team for further help. Now I will be sharing some stories, 3 anonymous stories with you. These stories have been anonymized due to privacy concerns, but still they maintain the core use case that I'll try to get, or the core messaging I'll try to get across. These stories include tips, they include mistakes you should avoid, and they include ways to avoid these mistakes. Let's go. Now, the first customer is a life sciences manufacturer, and they're also a Shield Advanced customer. Now, due to the stringent industry requirements within the life sciences industry, the customer had already complied with security best practices, such as VPC security groups, implementing VPC security groups, implementing network access control lists, and by placing the WAF or WAF in front of their applications. A quick tip here is network access control lists for Shield Advanced customers hold more than the eye meets the eye. When you're a Shield Advanced customer and you use a network access control list, our edge or border network mitigation services ingest whatever inbound rules you have placed for that subnet. And in doing so, we ensure that we are mitigating attack traffic at the border, thereby protecting your infrastructure down in the region. So it's quite important that as part of your risk reduction strategy, you include as many rules into the inbound network access control list as possible, and only accept traffic that your application expects. Either it's an infrastructure layer application or a web layer application. Now, to the situation with this life sciences customer. Essentially, the customer did not enforce origin protection. And due to that, the ill-intended or authorized users were able to directly access the customer's underlying infrastructure, which was an autoscaling group that contained EC2 instances. Essentially, what happened was that the attackers could successfully probe the internet-facing application load balancer and were able to discover it and send web request floats towards it. During this process, the customer escalated to the Shield Response Team, and we hopped on the escalation call in order to begin to analyze and mitigate the situation. In doing so, we quickly realized that the internet-facing web application load balancer was not properly secure with origin protection. In other words, we realized that the security group did not enforce that only Cloudfront IP address space was allowed to access the web application load balancer. Hence, the attackers were successful in reaching the target groups. On the escalation, the Shield Response Team recommended to the customer to create a security group that included only Cloudfront IP address spaces or Cloudfront IP addresses, and they add that to the security group of the application load balancer in order to enforce the origin protection. The result of this was we saw a drastic decline in the amount of web requests headed towards the web application, because now we had ensured that all web traffic would first of all hit the Shield Advanced protected Cloudfront distribution before it was forwarded to the application load balancer and finally to the target group, which contained the EC2 instances. The takeaway from this scenario is that customers should ensure that they are protecting their origins. AWS has several ways to protect your Cloudfront origins. One of those ways is what I mentioned earlier, using security groups on your application load balancer. In this diagram, you can see a snippet of various Cloudfront address spaces with prefixes that contain what Cloudfront may use at that given time. Now, this list evolves over time, and so we recommend that customers refer to the AWS security blog post that contains how to automatically update your security group. In doing so, a Lambda function would pull an SNS topic, which notifies it that there is a change in the security in the Cloudfront IPs, and it will automatically update the security group attached to your application load balancer, thereby keeping it up to date with the latest IPs and ensuring that only your Cloudfront IPs are available or are accessible to the application load balancer. Another option customers have, you can use this in unison with the initial option, but another option customers have is to use Cloudfront custom headers. With Cloudfront custom headers, you can ensure that your application load balancer inspects only headers that the Cloudfront distribution has injected into the request, the HTTP request. By doing so, you ensure that any request that doesn't contain that custom header you define is going to be dropped at the application load balancer level. You could also alternatively add a WAF in front of the application load balancer to do that inspection, do the web traffic layer inspection. There is a reInvent session that talks about this exact topic, which is origin protection using custom headers. I highly recommend that you go check that out. The final option we have for protecting Cloudfront distribution origins is known as origin access identity. And this is for your static assets that reside in an S3 bucket. With this option, customers have the ability to define a Cloudfront user that is going to be assigned to be accessible to access the S3 bucket only. So that means no other person outside that Cloudfront user will be able to access the S3 bucket, keeping your objects or keeping your data secure from prying eyes. The second scenario is a customer that is an e-learning platform. Now, this customer is a Shield Advanced customer and ran their e-learning platform on a compute instances. The platform was protected by WAF, and the customer was quite confident that their WAF had the required rules that had the efficacy to prevent any web request flood. But the customer, however, was missing an important mitigation and important protection, which is login was disabled. As part of OWASP Top 10 Security Risks in 2020, insufficient login and monitoring has been identified as a risk to web applications. And so we recommend customers ensure that all web application web ACLs have, web application firewall web ACLs have login enabled. The situation with this escalation was that the customer realized that the WAF rules, though implemented, were not sufficient in mitigating all attack traffic. And so they required additional assistance, and they reached out to the Shield Response Team for immediate assistance. The Shield Response Team joined the escalation call, and we attempted to parse the logs to identify the attack pattern. Because during escalations, once we join the call, we use our access that you've authorized us to your S3 bucket that contains the WAF logs, and we begin to parse this to identify attack patterns. In this escalation, we were unable to do this as there was no login enabled. Excuse me. And the consequence of that was that we were unable to identify an attack pattern. We recommended the customer, we walked them through how to enable login for their web application firewall. But unfortunately, this extended the mean time to mitigate. Now, mean time to mitigate is a success criteria for some customers, and they want to ensure that number remains at the barest minimum. Due to the situation, we had to ensure that we had login enabled to identify the attack pattern that the customer's application was seeing. Once we were able to identify the attack pattern, which we realized was the login page was being requested more than normal, we assisted the customer in creating a Readbased rule that set a throttle on login page requests. We have a security blog post that contains best practices on how to create web application firewall Readbased rules. The tip or takeaway from this is the web application firewall full login contains all the important criteria that we need in determining the attack pattern. Customers may opt in for sampled requests, but we realize that sampled requests do not contain all the information that we need because it's over a short amount of period and it just contains selected web requests. We need a comprehensive list or a comprehensive log of all HTTP requests that the web application is seeing. WAF uses Kinesis data firehose for ingestion and uses an S3 bucket for data persistence. For customers that have multiple accounts within an AWS organization, we recommend that customers take advantage of the Shield Advanced subscription that contains AWS Firewall Manager service as an included option. In doing so, you can ensure that you centralize compliance among all your web applications by using baseline protection, such as IP reputation lists against bad bots or against known malicious IPs. You could also ensure that you use baseline protection to provide protection against OWASP top 10 by either using the Amazon managed rules or by consuming third-party managed rules. The final escalation is a gaming customer. Now, this is an interesting escalation because with this escalation, we were quickly pulled into the world of DDoS extortion threats. 2020 saw a bunch of DDoS extortion threats face multiple of our customers. Now, for the customers who were already established with Shield Advanced, they were quite comfortable because they had a resilient architecture that would withstand web request floods or infrastructure layer attacks. For this one customer, they had not subscribed to Shield Advanced. And so in response to the threat they got, they subscribed to Shield Advanced. As a Shield Advanced customer, you can engage the Shield Response Team to review your architecture and to prepare for a DDoS event. So the customer here had an engagement with us where we recommended that the web-based architecture that uses a WebSocket protocol should change its architecture. So you can see here the customer's gamers were directly accessing the gaming application over an AIP. Now, this is not the most resilient architecture as it doesn't contain defense in depth. And so we recommended the customer change the approach as attackers could easily overwhelm the EC2 instance as it does not have the same level of bandwidth capacity that we have at the Amazon border network, which is where you will be ingressing your traffic if you use a Shield Advanced protected resource, such as Cloudfront. In this scenario, the customer could not implement Cloudfront, and they showed us what a snippet of that conversation between the DDoS extortion actor and them was. This is a Telegram conversation between the attacker and the customer. As you can see, the attacker was bragging that they were able to bring down any production server as they had a 50,000 strong botnet. We told the customer to be rest assured that once they comply with our white paper and they follow the white paper and comply with our recommendations to remain DDoS resilient, they will be able to withstand events. And even if they do see events that cause impairment, the Shield Response Team is available to respond to them as soon as possible. This was the architecture the customer eventually had to settle with due to the fact that they could not implement CloudFront distributions in front of our application. They directly associated the web application firewall to the application load balancer. Sure enough, the attackers made due on their promise and they flooded the customer's application infrastructure using a SYN flood. Because the application load balancer was protected by Shield Advanced, we were able to quickly detect it and protect against infrastructure layer attacks. The attacker realized this and had to switch up their strategy. In doing this, the attacker switched to an application web request flood, and they were able to impair the application, and the customer had to reach out to us for further assistance. When the Shield Response Team responded to this escalation, we had to analyze the logs as we had told the customer to ensure that they enable login on their WAF and also to authorize the Shield Response Team access to view these logs. During the escalation, we pulled the logs and we passed these logs, and we realized that the attackers were using a specific attack pattern. This pattern contained a user agent that was not consistent with the expected user agents the customer saw. So quickly identifying this, we created a WAF rule on the customer's behalf, and we defined that any HTTP request that contains a header that is, conforming with this unexpected user agent should be dropped. We also noticed another anomaly with the attack traffic. All attack traffic did not contain certain cookies that the customer's client will send to the web server. And so we created a WAF rule that looked out for cookies that matched a certain pattern using a regex pattern. With the assistance of the customer, obviously, we were able to define that pattern and look for any HTTP request that did not contain this pattern. With these two mitigation efforts, we were able to restore application availability for the customer's application. The customer during this event had also enabled Shield Response, Shield Proactive Response. Now, Shield Proactive Response is a recent feature that the Shield Response team released mid-2020, and essentially what it does is that it allows customers define application health using a Route 53 health check. Now, this health check is not associated to a Route 53 hosted zone. They're independent of each other, but they use Route 53 as a service. With the health check, you can define what the true application health looks like. And in defining this, the Shield Response team consumes this and monitors for application health. If we notice that your application is unhealthy and there is a corresponding DDoS event at the same time, we will use the contact information you provide to us. As you can see listed here, we call any of these numbers as you set priority for, and we request that you join us in a Chime bridge or any video conferencing service that you prefer. And once we join that call, we begin to mitigate. Now, we expect customers who use proactive response to have a SOC or a security operations center set up so that they know that they can respond 24/7. As we run a 24/7 mitigation service known as Shared Response Team, customers are required to add emergency contacts and to ensure that they have application health checks that define the true health of the application. A Shield Advanced Detection Engine uses anomaly detection, and so in unison with a health-based detection, we can improve the accuracy of the Shield Advanced Detection Engine. Finally, after the event, how should customers respond to this? I've listed a bunch of tips and tricks that we have realized over our different escalations that I believe Shield Advanced customers can take from this session and begin to implement within the architectures and environments. It's very important that as a Shield Advanced customer that uses an application that has a web application hosted in a compute capacity such as EC2 or ECS or Lambda, you should associate your protected resource such as an application load balancer, a Cloudfront distribution, to AWS WAF. As Shield Advanced requires WAF for visibility into your application layer traffic. Without WAF on your protected resource, we will not be able to detect anomalies that your application may be seeing. We highly recommend that you enable logging for your application, for your web application firewall. Now, we have had customers with privacy concerns who say that they have to redact certain fields. Given this, we respect your privacy, and security at Amazon is job zero. And so we will not require you change that privacy for anything. But this may impair our analysis. And so we would only be able to provide or profess solutions or mitigations to those attack patterns that we can see. It's also important that you understand your traffic pattern on a regular day when there's no DDoS event or an attack. And in doing so, you should set some sort of throttle on your WAF, on your web application. You could set a general throttle that says you expect X amount of requests within a 5-minute window. You could also set a throttle that says that for your most expensive resources, those are the resources that, if they are impacted, would cause overall application health. Set a more specific Readbased ruled on those resources to ensure that they stay up. You could also set a geo restriction if you are using an application that services a global audience. It's quite important that you reduce your attack surface by using security mechanisms such as network access control lists, security groups, custom origin headers, geo restrictions where possible. We also recommend that if you want to enhance, or you want to have another option of enhancing your response to DDoS events, you should use proactive response. Thank you very much for joining me on today's session. My name remains Fola, and please fill out the session survey at the end of this. Thank you.